Hey guys, what's up? This is Mr. Myassis here, and we are going to talk about position, velocity, and acceleration. Now, this is going to be kind of a long video, so I got to get going here. And if I talk too fast, well, you got pause, so pause me and go back and rewind. So basically, position, velocity, acceleration. Position we label as s of t. Velocity is the derivative of the position, v sub t, and acceleration is the second derivative of the position, or the derivative of velocity, which is called acceleration. All right, so that's the basic idea, what we're going to do here. So let's go and do this first example. And all we have the position function, so we're going to find the velocity and the acceleration function. So we're going to take the derivative, and that's going to be 3t squared plus 1, and that is going to be our velocity function with respect to time. Our acceleration function is going to be the derivative of velocity, which is the second derivative of position, which is 6t. All right, that's all there is to it. So that's the basic idea. Let's take a look at some examples where we would, actually use a lot of this stuff. So we have this position function. We're going to answer all these questions here, and we're talking feet and seconds. All right, FTS. What is the initial position of the object? The initial position is going to be when time is 0. So whenever we see initial, that usually means time equals 0. So all we're going to find is, what is s sub 0? So when we plug in 0 for t, we're going to get 24 feet. All right, so that's the initial position. What is the velocity of the object at t equals 1 second? So we've got to find the velocity function, and that's the derivative of position. So we're going to get 48t squared minus 72t, and we're going to plug in 1. So when we do that, we're going to get negative 24 feet per second. Velocity is in feet per second. All right, number 4. What is the speed? The speed is the absolute value of velocity. All right, because there's no direction in speed. Velocity is a vector. So we have both speed, magnitude, and direction. The negative here just tells us whether the object is going to the left, would be negative velocity, and to the right would be positive velocity. All right, our speed tells us what that magnitude is, so we're simply going to have 24 feet per second, right? Because we don't have a negative in this case. So what is the acceleration of the object? Well, the acceleration is going to be the derivative of velocity. So we're going to have 72. I'm sorry, not 72. I can't math right now, apparently. Wrong one. It is going to be 48 times 2 using the product rule, so 96t minus 72. So we're going to find a sub 1 because we want it at 1 second. So 96 minus 72, which gives us 20. Whoa, that's interesting. Per second, or 24 feet per second squared. It's the same as that. That's just coincidence. All right, so that's the acceleration. When is the object at rest? The object is at rest when it's not moving. When it's not moving, it has 0 velocity. So that's a velocity equal to 0. So we're just going to take our velocity function, 48t squared minus 72t, and we're going to set it equal to 0. And we're going to solve for that. So we're going to factor out a t. I'm sure you can factor out more than just a t. We're going to get t equals 0, and t equals 72 over 48. These are in seconds. All right. So these are the two places where the object is at rest. If this is just painting you, that's 1.5 seconds. But you don't have to do that because you can just leave it like it is. All right, let's take a look at some more here. Same function. When is the object moving to the right? Well, it's moving to the right when velocity is greater than 0. right? Okay, so let's go back here. Velocity is greater than 0. This right here is negative. It's moving to the left. So when is it moving to the right? When velocity is greater than 0. We found our velocity function was 48t squared minus 72 minus 72t is going to be greater than 0. So we're going to solve this, 24t and 2t minus 3. And we want that to be greater than 0, so we need to do a little number line here. And we're going to have 0, and we're going to have, what's this come down, 3 halves, or 1.5. All right, this is where it's going to be 0. Let's go ahead and test 1 here. We're going to test 1 in here, and that's going to tell us that all of these values are going to be negative. And these values are going to be positive and positive. And yes, we have to test the values because this is a quadratic inequality, so we got to test. Well, when is it moving to the right? It's moving to the right when it's greater than 0, so over here and over here. So when t values are less than 0 seconds and when t is greater than 3/2 seconds. Well, we don't have t values that are less than 0 seconds, right? So whenever our above 1.5 seconds is when we're going to have an object moving to the right. Okay, so when is the object moving to the left? Well, look we see it right here, between 3/2 and 0 seconds. Okay, and that we get just from this picture right here. So when is the velocity of the object equal to 48 feet per second? So we're going to go and take our velocity equation, formula here, set it equal to 48, and solve for t. So when we solve this for t, we're going to have to move the 48 over, and we're going to have to factor. And when I simplify and factor this, I'm going to end up with 2t plus 1 and t minus 2, 24 out here. So I'm going to get t equals 2 seconds. Now, why did I not include the negative 1/2? Because we don't have negative 1/2 seconds, okay? So we're not going to have negative 1/2 seconds. What is a displacement? Displacement is going to be where, my pen's not working, it's going to be, okay, notice here that we're going to go left, so from 0 to 1.5 we're going to go left, right? So 0 to 1.5 we're going to go left, and then at 1.5 seconds we're going to start going to the right again, and we're probably going to end up somewhere over here at 2 seconds. Well, actually, I know kind of what this looks like, and it actually doesn't go this far. It goes like right here, 2 seconds. So the amount of space that I went, okay, this is displacement. Displacement. And that's a vector, so it can be both negative or positive. The total distance, however, is going to be the total distance that I traveled. So displacement is s of 2 minus s of 0. S of 2 turns out to be 8, and s of 0 turns out to be negative 24. So my answer for that is negative 16 feet. And that seems weird, but then we're going backwards, right? So what's the total distance traveled? Well, from 0 to 1.5, s of 0 is 24. S of 1.5 is negative 3. And then s of 2 is 8. So I need to figure out how far did I go from 0 to 1.5. Well, from 0 to 1.5, I went 27 feet. And from 1.5 to 8, I went 8, 9, 10, 11 feet. Right, because negative 3 to 8. And if I add those up together, I get 38 feet. 38 feet. Okay. So that's going to be the total distance, whereas the displacement is how far did I go from 0 to my end. All right? All right. Whew. Getting through this here. So now I have a position time graph. Let's take a look at this, and remembering that the velocity is the derivative of time, of position, and the acceleration is the derivative of time, which is the second derivative of position. I'm sorry, the derivative of velocity. which is the second derivative of position. We're probably not gonna deal with acceleration right now, but we will a little later. Okay, so velocity is the derivative of position, so we're talking slope. Was the car going faster at A or B? Well, let's look at the slope. The slope looks like this here, but like this here. So which slope is higher? Which one's more sloped, I guess you could say? It's B. So it's going faster at B because the velocity is greater. Okay, so what about when was the car stopped? Well, we're looking for where is the car stopped, meaning where is there no velocity? Where is the slope 0? The slope is 0 right here. So between C and D. Between C and D. At which point was the car's velocity the greatest? So the velocity the greatest is going to be when is the slope the greatest? Slope here is right here. Slope here is like this. Slope here is very steep, and then like this. But this slope is negative, this slope is positive, so I would say B. Because say positive slope. And we're talking about velocity. Whereas when we say where's the speed the greatest, we're talking about the absolute value, which in this case, E definitely looks like it's sloped the greatest, and we're going to say that is E. All right, because it's the absolute value of velocity. All right, last few here. Vertical motion. Now, vertical motion are problems like a golf ball. You hit the golf ball, it goes up, and then it comes down. So it's parabolic. All right, so it means they're at a maximum height where the velocity is 0, right? Because this is the slope of the tangent line is where you're going to have your maximum height. So find the velocity function. So the velocity function is the derivative of the position. So I have negative 32t plus 48. And then I'm going to go ahead and do number 17, which is at what time does the ball hit the ground? That's when s of t is 0. So we're going to go ahead and set this equal to 0. 160 equals 0. And we're going to solve for t. So when I solve that, I can take out negative 16 and divide it over, and I'm going to end up with t squared minus 3t minus 10 equals 0. And that's going to factor to t minus 5 and t plus 2. I know I kind of skipped some algebra there, guys, but I'm hoping that you can figure out that algebra, factor out, and then we're going to get t equals 5 seconds. All right? All right, what time does the ball reach its maximum height? Well, I just told you that's when the velocity is equal to 0. So our velocity function was negative 32t plus 48. We're going to set that equal to 0. And we're going to get t equals negative 48 over negative 32 seconds. And you can leave it like this. Or if it's really bugging you, that's 1.5 seconds. Okay? All right, so that is position, velocity, and acceleration. See you later, folks.